Okay, so today we're going to look at topic two's extra review. That's on page 54 and 55. So what you'll notice is that we have translations, okay, and then we have reflections across x equals 3, y equals x, and y equals -1. So what I want to talk about just before we get completely moving is the rule for reflections. So it took me a little bit of time to kind of look through research and really figure out what the intention of these problems were. So if we reflect over a vertical line, such as like x equals a. Now a can be any number. It can be x equals 3, x equals -2, but it's a line other than something on the axis, or y equals x or y equals -x, i.e. the standard ones that we've seen so far. So the rule here, the way to figure out the coordinate notation is your coordinate notation becomes you're going to double that a value. So if x equals 3, you're going to double the 3 and then subtract off the x value of the coordinate and then leave y alone. So there's your coordinate notation, and that's going to come into play down lower. You'll see this kind of format again. But what if the line is horizontal? Okay. What if the line is horizontal? So let's say like a y equals an a. Okay. The rule is going to be exactly the same, but to the y coordinate. So we're going to go 2a minus y. Uh, this is sort of a notation I haven't seen before, but having tested it on a lot of the points, it is what we're going to use as the coordinate notation. Now the a will change, so you'll have an actual number, a numerical value in these two spots. But this is the equation or the general coordinate notation for a reflection with a line not on one of the axes or not one of our typical pieces. So let's go ahead and do the translations that we're being asked for. It says graph the image of each shape after the given transformation. Okay. Then write the transformation in coordinate notation. Well, we're going to go up 2 and right 7. Okay, so from R, I'm going to go up 2, and to the right, 1, 2, 3, 4, 5, 6, 7. Here we're going to take P and go up 2 and right 1, 2, 3, 4, 5, 6, 7. And Q should just be a little bit further over there. So what happened here? Well, we went to the right 7 and up 2. Okay, we should start to feel a little bit more comfortable there. Well, now we're going to go left 4 and down 6. So I'm going to take each coordinate and go left 4, 1, 2, 3, 4, and down 6, 1, 2, 3, 4, 5, 6. Now, let's see, let's take B. B is down 1, 2, 3 from A, so I can say it's down 3 from A. Okay, let's look at C. We're going to go to the left 4, 1, 2, 3, 4, and down 6, 1, 2, 3, 4, 5, 6. Okay, and what was our rule here? We went to the left 4 and down 6. Okay. So now this one, this image that we're looking at, has already been shifted. Okay, and it's already been shifted 5 to the left and 3 up. So I want to go the opposite to get to the pre-image. So I want to go 5 to the right and 3 down. Okay. 5 to the right and 3 down. So I'm going to take everyone and go 5 to the right. So let's look at V prime. 1, 2, 3, 4, 5. 1, 2, 3. So there's the original V. Okay, let's move W. 1, 2, 3, 4, 5. 1, 2, 3. Okay, let's see. 4. S is just 4 lower, so you can kind of calculate that if you want. Don't actually have to do much to do the translation. And let's see, where's U? U is 1, 2, 3 higher than T. 1, 2, 3 higher than T. Okay. So now we're supposed to say, what was the rule to go from the original image, that's the one we just drew, the pre-image, over to the image. So what did we do? What was the translation? The translation was left 5 and up 3. Okay, so let's go down to our reflections. And this is where those new set of rules from the top, from the beginning, are going to come into play. It says reflect a point over an axis. We negate the x or the y value. We've seen that already. If the line of symmetry is not one of the axes, we're going to have to do something a little bit different. And I didn't actually think that the notes here were super helpful, so I went to look somewhere else and found this actually pretty straightforward. So reflection across the line x equals 3. So here it is. Let me draw in x equals 3. So there's x equals 3. Now, from a logical perspective, the way we've been doing this is we're going to say, okay, well, f's not going to move. Okay, D is 1, 2, 3, 4 to the right. So we're going to go 1, or to the left, excuse me, we're going to go 1, 2, 3, 4 to the right. And E is also 4 to the left. So we're going to go 1, 2, 3, 4 to the right. So really graphing these is not difficult, right? Graphing these is not difficult at all. But the rule, okay, the rule is 2a minus x comma y. Well, what's our a value? Our a value is 3. So we're going to have 2 times 3 minus x comma y. Okay, so the rule is going to be 6 minus x comma y. And what if I wanted to verify that? So let's look at D. D is the point -1 comma 2. Well, what if we apply this? Okay. What if I say that that's 6 minus the x value of -1 comma 2? So 6 minus -1 is 7 comma 2. And if we look, that's exactly where this point is located. Okay, so the rule does work. Okay, we go on to the middle term into reflection across y equals x, and we know that the rule there is just simply to switch the x and the y values. So I'm going to go ahead and plot our points. I'm going to say u is 3, 2, w is 5, -4, and v is 1, -4. So we can switch those. Where's u prime going to be? U prime is going to be at 2. Do that one in a different color so it stands out a little bit better for you. It's going to be 2, 3. 5, -4 is going to become -4, 5. And 1, -4 is going to become -4, 1. Okay, so let's go to the next one. We're going to reflect across the line y equals -1. There it is. So I've drawn it in for you. You can see it. Now, from a perspective of just graphing, u is 1 below, so it's going to shift to 1 above. Let me put this back in blue. T is 1, 2, 3, 4 below, so we're going to go 4 below, above. S is 4 below our line of symmetry, so we're going to go 4 above. Okay, fine, we can graph it pretty easily, but we're going to need a rule because that's what we're asked for, and the rule is y, comma, 2a, or excuse me, it's x, comma, 2a minus y. Well, what's our a term? Our a term is -1. So I've got -2 minus y. And again, we can test this, and let me go ahead and test this with u. U is the point 3, -2. So let's apply our rule. Our rule is going to be x, comma, -2 minus the y value. So it's going to be 3, 0. And is that where we are? Yes, absolutely it is. So let's go ahead and turn the page, and we're going to be doing a little bit more of the same thing. So we're going to go across the line x equals -4. So here's x equals -4. Okay, so let's go ahead and move all of our points. L is 2 to the left, so we'll go 2 to the right. K is 3 to the left, so we'll go 3 to the right. M is 1 to the left, so 1 to the right. N is 1, 2, 3, 4 to the left, so we're going to go 4 to the right. Wait, over there. Okay, and what's our rule here? It's 2a minus x comma y. So what's our a value? It's -4. 2 times -4 is -8. Okay. Now we're going to go across the x-axis. So this one is a little bit easier. Here's our x-axis. Okay, remember the rule for this one is just simply -x comma y, a little bit easier. So G is 4 above, we're going to go 4 below. C is 2 above, we'll go 2 below. H, 3 above, so we'll go 3 below. F is 4 above, we'll go 4 below. D is 2 above, 2 below. E is 3 above, so we'll go 3 below. And then we connect our points. Okay. Now we're going to go across the line y equals 3. So let me go ahead and draw that for us. Where is y equals 3? There it is. Okay. So for all practical purposes, F is 1, 2, 3 below, so we're going to go 3 above. E is 1 below, so we go 1 above. Same with D. C is 3 below, so we'll go 3 above. B is 5, so we'll go 1, 2, 3, 4, 5. And A is there as well. Okay, and then the rule here is x comma 2a minus y. What's our a value? It's 3, so we get 6 minus y. Okay, so now we're going to look at rotations, things that we have seen before. So before I even do any work, I'm going to go ahead and plot W. W is going to be 2, 5. V is 3, 5. R is 2, 1. S is 5, 1. Okay, so the rule is a 90-degree counterclockwise, so this is a little bit of a refresher. Okay, so what are our pieces going to be? What's W going to become? It's going to become -y, x. What's V going to become? -y, x. What's R going to become? -y, x. What's S going to become? -y, x. And we're just going to plot those points. So there's W, V, R, S. What did I miss? U. Let's get a U in there. What's U? U is 3, 2. And T is 5, 2. So where's U prime going to be? U prime is going to be -y, x. V is going to be -y, x. So -2, 3. And -2, 5. So what is it? T. There we go. Okay. Let's go 180 degrees about the origin. So 180 degrees about the origin is -x, -y. Okay. 90 degrees clockwise about the origin is going to be y, comma, -x. Now we've seen a bunch of these, so I'm going to spare us a little bit of time and say the best way to do these is to write down the coordinates that you see that are given for both of these problems, write down the translation based on the rule, and plot them. Okay, we've seen a bunch. You can go back in the other videos and look, but I do think you've seen enough and you have one prior as a good example. Again, if you want, I can walk you through those, but I think just having the one on the left is a really good example, and as well as having the rules for the next two. So the next one, we've seen a little bit of these. We have y equals a x minus h squared plus k, and it's telling you a is a dilation or a flip, so that's going to stretch or shrink the graph and flip it upside down. H and K are the vertex. H and K are the vertex. And remember, we're going to go opposite sign here. So the vertex being sort of the very bottom of our curve here. So that's going to be at 3, -1. Okay. Well, I have found it already, so it's 3, -1. And when we put it into the equation, we're going to say we have x minus 3 squared minus 1. Okay. Well, what's the vertex here? Very kind of bottom curve of the graph. So that's -3, 2. And our equation is going to be y equals x minus -3 plus 2. So y equals x plus 3 squared plus 2. Remember I mentioned opposite sign. There's a minus sign here, but the graph went to the right. And there's a plus sign here, and the graph went to the left. It's because of a double negative that you've seen in that middle example. Okay. The last one has given us an equation. There's a positive in here. So if we're thinking opposite directions, that's going to go to the left 2 and then down 3. Okay, so the left 2 and down 3, and that will be your vertex. So we've got -2, -3. So that's the end of page 54 and 55. Again, I did not graph these for you because I think we've seen a fair number of them, and the rule is at the bottom. So graph or off to the side, just like I've done over here. Feel free to write out those coordinate points. Okay, 180 degrees about the origin, you should end up down here. Okay, and 90 degrees clockwise, you should mainly end up down here as you graph it. Okay, so hopefully you're okay at this point, and yeah, feel free to let me know if there's any questions.